This is Secondary 2 Honors Module number 8, second video. This is on what's called synthetic division. Synthetic division is another method that we can use to divide polynomials, and again it serves a similar purpose. We are going to try to find factors or solutions, and you can actually use synthetic division to work down to quadratic, where you can use a quadratic formula. So if you had something, like x to the 5th power, and then some other stuff, you could divide it by a linear equation to find out what some factors were. There's a lot of other things you'll learn in the future about how to get down to that point, but we're just going to worry about the synthetic division in this video. The way you do synthetic division, first you need to make sure that your polynomial that you're dividing is in standard form. So all of your exponents need to be in descending order. And if there were any missings, like if there were no x squared there, you would need to put 0x squared. Just make sure that all of the places are accounted for, so you could put placeholders in if you needed to. Now with synthetic division, you are worried, or you're just going to deal with the coefficients, and so you're going to take the coefficients and you're going to put them in order, and then you make like a little t-square, and then you're going to take what you're dividing by, so in this case it's x plus 2, and you are going to use the 0 that would come from that, so negative 2 in this case. You're going to put the negative 2 right down here. Okay, so the procedure is the first number you're going to just bring it down. And then you're going to do some multiplication. You're going to do negative 2 times 1, and that's negative 2. And then you're going to add these two, and that's going to be negative 5. Then negative 2 times negative 5 is positive 10. And then you're going to add right there, and that's negative 1. Negative 2 times negative 1 is 1. And then you are going to add, and you get negative 1. Whoops, actually, negative 2 times negative 1 is actually 2. And you're going to add that, and you'll actually get a remainder of 0. Okay, so what this is this last number, this is your remainder. It also has some other uses, but for right now that's just the remainder. And then these numbers right here, those are going to be the coefficients of your quotient. So what you're going to do is you're going to write your quotient as, since we start with x to the 3rd, we're going to go down 1 and x squared, 1x squared minus 5x minus 1, and since it's remainder 0, that's it, that's your quotient. Okay, let's do another one. X squared plus 2x plus 1, we're going to take our coefficients and we're going to put them 1, 2, and 1. And then this right here is going to give us negative 1, so we're going to put negative 1 right there. So bring down the first one, multiply, add those two, multiply, add. And so our quotient, since we start with x squared, this is going to take us down to x plus 1. And that is our quotient. And again, that means that x plus 1 times x plus 1 is equal to x squared plus 2x plus 1. So our factors would be x plus 1 and x plus 1. Our zeros would be negative 1. Okay, for example 3, pause the video and try it and see if you can come up with the right answer. Okay, so what you should do is you should have it set up like this. Then you're going to bring down the 1. 1 times negative 5 is negative 5. 15 minus 5 is 10. Negative 5 times 10 is negative 50. And 50 plus negative 50 is 0. So what we've got is we've got x to the 1st power plus 10. Remainder 0, so x plus 10 is the factor. X plus 5 is another factor because it goes in evenly. You see no remainder. And that would also tell me where my zeros were if I wanted to know where that parabola crossed the x-axis. Okay, example 4. This one is a 3rd degree polynomial, or cubic polynomial. And that just basically means that we have more steps. So I'm going to take the coefficients, make sure you get all the signs. And since this is x minus 2, I'm going to put a positive 2 right here. And then just go through that process. Bring down the 1. 1 times 2. 2 plus 2. 2 times 4 is 8. Negative 13 plus 8 is negative 5. And 2 times negative 5 is negative 10. Remainder 0. Which means that my quotient is x to the second power, because I come down 1 from the x to the third, plus 4x minus 5. Now that means that x squared plus 4x minus 5 times x minus 2 is going to give me that cubic function that I had. If I wanted to know what the roots were, what I would need to do is then I would need to continue and maybe factor this into something that I could find what the rest of the roots are, and so then I could find out that my roots of this function were 1, negative 5, and 2. So those are the 3 zeros of this function. Now for our purposes, all we're doing is finding the quotient, but I'm just trying to show you what you would use this for in the future. Example 5, pause the video and do this problem. Okay, so you see on this one we have a remainder. And so with synthetic division, as with long division, when you have a remainder, you've got, this is the polynomial part, and so you're going to again bring down your degree, so 2x to the first power plus 5, and then just like with long division, you're going to say plus 25 divided by, and then whatever that supposed factor was, and then this is your answer. So the x plus 5 isn't a factor because it doesn't go in evenly, but that's what you get. You would get 2x plus 5 with a remainder. Okay, now for example 6, the question is x plus 8 is 0 of x squared plus 2x plus 32. So if this is a factor, then that would mean that when I did the division, I would have a remainder of 0, which would make negative 8 a 0 of the function. So what I can do is I can just take the coefficients and do synthetic division, and if I get a remainder of 0, then that means it is a factor, it is a 0. So when I do the synthetic division, I find out that I do in fact get a remainder of 0, so the answer is yes, x plus 8 is a factor, or negative 8 is a 0. You can also use synthetic division to evaluate a polynomial at a given point. So for example, if p of x is equal to 4x squared minus 5x plus 3, and I wanted to know what p of 2 was, then previously what we've done is we've done this. Put in substitution. So I'm going to have 4 times 4 minus 10 plus 3, which is 16 minus 10 plus 3. 16 minus 10 is 6 plus 3, 9. So we would say that p of 2 is equal to 9. That means that when x is equal to 2, y is equal to 9. Now I can do the same problem, but I can use synthetic division to find what p of 2 is. And the way that I do that is I will take the coefficients and I will just do synthetic division, dividing by 2. My remainder, when I do the synthetic division, that is p of 2. And so that's the way that you can do that. That's especially good for complicated functions when your numbers get kind of big and it's kind of hairy to do that. So with this problem, we're going to put the coefficients down. Now one thing I want you to notice is that here we don't have an x squared or an x. And so what I have to do is I have to put in zeros in those places. So this is my x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. So you have to make sure you have all of those in there, or else the division does not work properly. Now since negative 3 is what I want to evaluate, that's the number that's going to go right here. So it doesn't mean that this is guaranteed to be an easy problem, okay, but it is a nice way to work it out. And so negative 3 times negative 54 is 162. And then 0 plus 162. Now negative 3 times times 162 is negative 486. And 0 plus negative 486 is negative 486. Negative 3 times negative 486 is 1458. And negative 4 plus 1458 gives me 1454. And that means that would be my remainder if that's what I was doing if I was doing division. But all I'm doing is finding P of negative 3, and that's equal to 1454. So I could verify that using the substitution and plugging negative 3 in for x everywhere. And if you do that, you find out you do have the right answer there, but that is just one way that you can use that to evaluate functions. Okay, you're now ready to complete your practice page, and then when you're done with that, you're ready to grade it and take the test, and then you will be done.